Bismillah ar-Rahman ar-Rahim, my dear students of the course Biopharmaceutics and Pharmacokinetics 2, third year Ajman University. Today we are going to talk about calculation of bioavailability parameters. Bioavailability parameters. In this topic, we will be talking about method of residuals and the Wagner-Nelson and Nelson method that will allow us to calculate Ka. Ka is ايش حكينا rate of absorption constant. It is the door through which the drug gets to the systemic circulation. Also we will talk about calculation of F, اللي هو bioavailability, using plasma data and urine data. Now, before we start talking about these things, let's remember what we talked about in our last presentation. In our last presentation, we talked about pharmacokinetic of oral administration. And we looked at the effect of Ka, F, on concentrations and the time to reach ايش اللي هو البيك concentration. For example, we said that the larger the Ka, كل ما كانت ال Ka larger, يعني faster الabsorption, we will reach the maximum concentration ايش faster, and this maximum concentration will be higher. Regarding F, we said that F will affect all concentrations at all times proportionally to what happened to F, اللي هو bioavailable fraction. يعني if F doubles, all the concentration at all times will be multiplied by 2. Okay, now what is the definition of bioavailability? شو هي الدefinition تاعت bioavailability? The definition, of course, all of you are familiar now with the definition. فهي it's the rate and extent of drug that reach the systemic circulation or the site of action. فإذا عندنا شغلتين, rate وعندنا extent. مين اللي بيعبر, which one describes the rate? اللي بتسوي description للريت هو ال Ka, واللي بيسوي description للextent هو ال F. That's why it will be important for us to look at how we can get these two parameters. Okay? إذن rate is controlled by Ka and the extent is by F. طيب, the first thing we will talk about, or we'll start about, is the calculation of Ka, and we are going to talk about an important method that is applicable in pharmacokinetics to different scenarios, and one of the scenarios اللي هي ايش calculation of Ka. اسمه method of residuals. What do we mean by residuals? Residuals is what remains. يعني when, for example, you subtract something from something, what remains is the residue. It's also called feathering method. Feathering method. إذا نحكي لها كمان FEATHERING. feathering. الفeather جاي من الفeather, الريش. Okay, what you find on birds that will help them fly. So it's called method of residuals or feathering method. Now why do we use this method? In order to calculate ايش ال Ka. طيب, in order to use this method, في هناك conditions that must be satisfied in order to use the method of residual. The first condition إنه absorption and elimination. إذن absorption and elimination, both processes, هذا process وهذا process, both are first order. حلو. طيب, the second thing is that you have Ka and you have Kel, right? Now the other condition is that one of these rate constants must be much higher than the other. يعني الKL or الKa is much more than the higher, and usually this is the door and this is the window, and the door is usually much bigger than the window, and this is important for the drag to accumulate in the body. Otherwise we will not have sufficient concentration in our system if KL is much higher than Ka. So one of the rate constant must be higher than the other, and to get accurate results, this rate constant must be at least 5 times the other rate. يعني كل ما كان one of the rate constant is much higher than the other, the higher, the more accurate your results will be. Okay, these are the two conditions. Now you will know why we are talking about one rate must be much higher. If you remember the equation that allow us to calculate the concentration of the drug at any time following oral or extravascular administration, this is the equation. Okay, and if you remember, we said that this is constant. صح؟ حكينا إنه this is constant. Okay, طيب, so for this constant I can consider it as A. نعتبر هذا الكونستانت A. A شو هو؟ what is A? A is equal to F الدوز of Ka divided by V of Ka minus KL. طيب, this is A represented by A multiplied into the difference between two exponents. Okay, so what I can do, I can multiply A في E us minus KL في T and A في E us minus Ka في T, and this is what I will get, right? طيب, look at this one. We said that one of the rate constants, which is usually Ka, is much higher than Kl. معناته the value here becomes higher faster than the value here. يعني after some time, this exponent here will approach 0 while this is still going on. Is an e to the power of minus Ka في T after some time. Okay, مش بالبداية, after some time, because Ka is much higher than Kl, after some times e to the power of minus larger number than here, this will go to 0. صح؟ مش حكينا e, we said that e to the power of minus large number will approach the 0. So طبعا approximately, when we see 0, approximately. So let's say the following: after some time, we will call it late. This exponent will be, هذا الexponent will be or will approach 0. فشو بضل عنا؟ A في 0 بصير عنا 0, right? So the remaining is ايش؟ Cp equal to A في E os minus KL في T. هذا متى؟ After some times. And what did we call it? We call it Cp. We call it late. So here we will say late. طب does it remind you of something? هل هذا بذكركم equation في something? If you remember the equation Cp0 is equal, sorry, مش Cp0, Cp is equal to CP0 في E أس minus KEL في T. It's very similar. If you put it in simulograph paper, you will get straight line, right? With this one. The same is here. So after some time, the data points on your simulograph paper can fit into a straight line. شوفوا لو ناخذ اللن الطرفين هون بصير لن CP late is equal to ln A minus KEL في T. إذن if I put the data, my data on simulograph paper, يعني for example, let's say Judy, she is doing an experiment where she gave a medication to a patient or to a subject, and she started collecting blood samples and analyzing the concentration in the blood samples with time. As time passes, the concentration first will increase and then will decrease, right? So if she takes these data points and she puts them in simulograph paper, she will see that after some time, this usually after the peak طبعا, after the peak concentration, she will notice that the data points fits into a straight line. Okay, and this straight line is governed by this equation whose CP late. طبعا ليش late? Because it's after sometimes after the peak concentration. It will be governed by this equation, or the straight line by this equation. Okay, let's see what happens here. Judy, she used the data points. Okay, and you will see that here we have a straight line. هلا لو جينا سألنا, if we ask مصطفى مثلا, if we ask him this straight line is governed by which equation, he will tell me it's by this equation, ln CP late is equal to ln A minus KEL في T. معناته if he extrapolates, هون سوى extrapolation, شو راح يكون هاي النقطة راح يقرأها, he will read this point as A. If I ask what is the intercept, it's ln this point, لأنه احنا we are talking here about logarithmic axis. Okay, logarithmic axis. إذن this point you read it as A, so the number here is equal to A, and the intercept is ln this number. Okay? طيب, what is the benefit now from this straight line? The benefit from this straight line is that you can calculate two things. First A, and you know that A equals to what? F في الدوز في ال KA divided by V في KA ناقص ال KEL. Okay? So first, we can get this value. Of course, we know the dose. We don't know still the Ka. And what about the KEL? Now, the good thing is that from this straight line, as I said, we can benefit by calculating also the slope. And the slope will be equal to إيش? Slope will be equal to minus ال KEL. Okay, I hope this is very clear to you. Okay. طيب, where is the K? We still haven't calculated the K. Then let's go back. Now we decided that CP late is equal to A في E أس minus KL في T. And while we are calculating, we wanted to calculate Ka, we actually calculated KEL. فهذا advantage. إذن if I ask you what is the advantage of feathering method أو residual method أو method of residuals, واحدة من الادفانتيج إنه we are able to calculate KEL. طيب, خلصنا؟ لا ما خلصناش. طيب, see, this straight line اللي هو تاع CP late that governs CP late, okay, is different from the actual concentration اللي هي Judy, she took the samples and she measured. It's different. هذا ال straight line is different here, صح؟ هنا في اختلافات. Okay, you'll see that there are differences between the straight line تاع CP late وايش ال actual concentrations. هدول هم ال actual. These are the actual concentrations. والconcentration هون ايش؟ تاع CP late. هذا خط بدنا نسميه the CP late line. وهذا اللي هو the real concentrations. The CP late and the real concentration become equal or equivalent or similar at this line. طبعا ممكن point here and point here and point here. بس we consider them to be similar لأنه this line is supposed to reduce the error. So we consider them as similar. إذا في اختلافات هون صح؟ طيب شوفوا لو أنا أجي if I come and I write the following CP اللي هو concentration at any time is equal to إيش؟ هاي بدنا نرجع هون A في E أس minus KL في T. شو هذا ال A في E أس minus KL في T؟ هو ال CP late حكينا هيو. CP late is A في E أس minus KL في T. فإذا هنا CP is equal to CP late طيب ناقص A في E أس minus KA في T. Okay? إذا this is the equation بتصير. الإيكويشن بتصير CP equal to CP late minus E أس minus KA في T. طيب شوف شو بصير if you take this side بتصير CP late minus CP and you take minus A في E أس minus KL في T here, so it will be positive. Okay, بصير عندنا A في E أس minus KA في T بصير عندنا يساوي ايش؟ CP late ناقص CP. شو هو CP هون؟ This is the actual concentration اللي هي جودي she measured from the blood samples. والCP late اللي هو من straight line. If I take CP late ناقص CP I will get ايش؟ A في E أس minus KL في T. طيب لاحظوا انه السي بي ليت والسي بي بيكونوا similar at late time. يعني هذا التراكيز الحقيقية the real concentration will be CP late ايش after some time. فإذا the difference will be zero after some times. عشان هيك A في E أس minus KA في T will be zero after passing some times. But initially في البداية see, you have differences, right? And we are ish. We want to focus on these differences. They are the ones that are relevant to the calculation of Ka. شوفوا هلا. If I take len both sides, okay? أخذت len السي بي ليت ناقص سي بي ولن this side. شو بتصير هاي؟ بتصير len ال A لأن ال A minus KA في T. اوكي طيب وهاي بتصير ايش؟ لأن ال CP late ناقص CP. إذا I will take CP late ناقص CP at early time. At early time اللي هذا التايم when I have differences. شوفوا هنا differences big and then get smaller and eventually you have zero. When you have zero, then you don't need to look at the difference. So we are looking at the difference at early time between CP late and CP, and then we are taking len that difference. So len that difference will be equal to len A minus KA في T, and here شو في عندنا now? Let's see. Okay. So as we discussed, this is the real concentration. The green one is the CP late from which we calculated actually اللي هو ال KL. The intercept is A. Okay, here CP late ناقص CP will be A في E أس minus KA في T. طبعا as I said, at late time the difference is 0, so you have 0 this one, because the absorption process has ceased. The absorption process has ceased. Okay, so now we want to look at the difference here. Okay, we want to look at the difference. So if we look at this equation, لن شوفوا هون شو مكتوب, what is written here, residual. Residual means what? Residual means CP late minus CP. This is the residue. Okay, so ln this difference will be equal to ln A minus KA في T. شوفوا, you on the same simulograph paper, على نفس simulograph paper, you find the difference between the straight line, okay, at different times, okay, with the real concentration. طيب, how do I get the concentration from the straight line? كيف أحصل على ال CP late? How do I get it? Okay, شوفوا. First, look at your data point here. For example, let's assume that this point here, this is the first point, is at 0.25 hour. إذن هاي النقطة متى؟ At 0.25 hour, يعني ربع, quarter of an hour. So at this time, this is the real concentration. What about CP late? This is the concentration of CP late. But how can I read this one? You have to go horizontal line and read it from directly from the scale. Okay, for example, here this is 1, 2, 3, 4, 5. Let's say it's 5.3 مثلا, for example. Okay, but what about this one? Let's say it is 2, فبصير عندنا 5. Let's say, for example, 5.3 minus 2, and that is your residual. At what time? At 0.25 hour. So you put the data point, so you will have a data point, for example, here, and another data point here for the difference at half an hour maybe. Okay, وكمان another at 1 hour maybe. Okay, and let's say 1.25 hour, for example. Okay, so you put the data points and you draw the best fitting straight line. The slope of this best fitting straight line ايش راح يكون? Equals to minus KA. طب how do I calculate the slope here? Do you know how? So you take two y's, for example this number and let's say this number. Okay, فبتقولوا ln this concentration minus ln this concentration divided by this time minus this time, about 2. This will give you ايش? Minus KA. So you can calculate KA. طبعا KA is in time to the power of minus 1. Okay, طيب, so now we are able to get what? Let's look back at our equations here. See, the dose is what we have given. يعني Judy, she gave the dose. She knows how much she gave. She was able to calculate KA and KEL. So everything is known. كل شيء موجود except ايش? This one. Except F على V. What she can get? She can get this ratio اللي هو F على V, اللي هو bioavailable fraction divided by volume of distribution. So she cannot get V directly, okay, or F directly. She cannot do that. She can get the ratio, okay, because she knows A and she knows all these parameters or input, such as the dose. So the only thing that she can calculate is F على V. طيب, you know that F, شو ال value of F? F will be from 0 to 1. صح ولا لا? Because 1 means 100% bioavailable. 0 means nothing is getting into the systemic circulation. Okay? ف 0 to 1. طب what about the volume of distribution? The minimum volume of distribution is probably 5 liters, right? And usually it's much higher. So if you want to divide a value that is 0 to 1, let's say it's 1, by the volume that is maybe very large, like for example 25 liters or 1000 liters or 500 liters, and if you want to do it in ml, even it will be much higher. If you want to divide them, the number will be very small. Okay, so it will be, for example, let's say 0.001, for example. So when you want to compare drugs, or you want to compare between patients, and you get 0.002, you don't feel that there is much difference. Okay, that's why this ratio is usually reversed, يعني made as V على F. Okay, so the number will be, for example, 1000 or 2000. Okay, طبعا the unit will be the unit of V, because F does not have a unit. So 1000 liter, 2000 liter, V على F. Okay, is this clear? So we prefer to do it like this, as I said, because إيش حكينا? Because these small numbers will be difficult to compare. This is more obvious. هنا الديفرنس واضح. هنا الديفرنس, you can say 0.001, the difference here. But see, the difference here is 1000. Okay? طيب, now we will go into more practice, so you get, or you absorb everything that I talked about. Okay? Look at the following example, and we will solve it together. ماشي؟ راح نحلها مع بعض. طيب, look here. Here you have time. Time of what? Time of drug sampling. يعني when Judy, she went and she took blood samples, she took it at quarter an hour, half an hour, three quarters an hour, at 1 hour, 1.5 hour, 2 hours, 3 hours, 4 hours. So she took a sample, blood samples at these times. Then she analyzed these blood samples corresponding to time. For example, at quarter an hour, it was 1.91 milligram per liter. At half an hour, it was 2.98, etc., etc. Okay? طيب, what Judy did, she went into a simulograph paper and she plotted هيو اللي هو التايم مع الكونسنتريشن that she got. She plotted them, and usually, as I said, after the peak concentration, she noticed that the data points here, they can make straight line. Okay, so she used them. Maybe she ignored this one and this one and this one. Why? Because they maybe they are before the peak concentration and they do not fit the straight line. So she started from here till here. Okay, هذا الخط طبعا is the CP late line, and then she extrapolated, and طبعا من هنا she can read A. Okay, طيب بعدين شو سوت؟ Okay, Judy, she went to the time 0.25. ايوه 0.25 هون. She went to the straight line اللي هو تاع السي بي late, and she read the concentration. ايوه وحطته. Now the concentration here is let's CP late is 5.23 at each time 0.25 hour. طيب بعدين راحت على half an hour. This is half an hour. She went to the straight line and she read the concentration from the y-axis ولقته at half an hour الCP late كان 4.98. اوكي بعدين راحت على 0.7 راحت على this time 0.75 راحت على الخط here on the straight line. She read the concentration وبعدين حطته هون 4.73. شوفوا she did also at 1 hour and 1.5 hour and at 2 hours. You will notice what? You will notice that the difference starts to become small. Here they almost become similar. Then she stopped. Why she stopped? Because now the data points she used for straight line will be the same or similar to the actual concentration. يعني the straight line with actual concentration are similar. So I consider the difference is zero, even if there is very small difference between them. In practice, this difference even can be negative. يعني ممكن the straight line concentration is less than the actual concentration. So in this case, you stop. You don't need to go further, and you can consider that CP late and the actual concentration are similar. I actually use them. I use them for what? I use them to construct the straight line. خلاص معناته they are similar. طيب طبعا what you see here شو هذا اللي هو تاع CP late. It tells you that CP late equal to 5.5 في E to the power of minus 0.2 في T. طبعا how did they find this? طبعا because CP late is A في E أس minus KL في T. طيب A معناته هون they read A as 1 2 3 4 5. They find it to be 5.5. They read it as 5.5. طب والKEL from the slope of this line. Okay, so the slope of this line is equal to minus KL. Is that clear? Okay, now they took the residue between the CP late and actual CP. هذا هو الريزيديو. Okay, so it's at 0.25 or quarter an hour, the difference is 3.32. At half an hour, the difference is 2. At 0.75, it's 1.19. Say they put the data points here for the residue, هذا residue line. They put the data points and they draw the best fitting straight line. هلا what governs this straight line اللي هو ايش؟ لن الريزيديو خلينا نشوف مرة ثانية. ايوه لن الريزيديو equal to لن ال A minus KA في T. إذن what I can get KA from the slope. Slope is equal to minus KA. And I can get also A, which is similar to the CP late point here at y-axis. طيب, so this residue line is شوفوا هيو ال A في E أس minus إيش 2.05. شو هذا الماينس 2.05? It's minus ال KA, يعني ال KA is 2.05 في T. إذن we were able to get اللي هو ال KA value. Okay. I hope this is clear for you. You can practice this one, so you can be professional in doing this. Residue method is not only used for the calculation of Ka, it's also used, for example, in describing the two compartment model. Okay, so they use the residual method. That's why it's an important method. Is it clear? Okay, now we will talk about the lag time. Lag time. What do we mean by lag time? Lag time, it's the time, because it's time, I'm talking here about time. It's the time before the start of the first order absorption process. Yani, for example, if you take an enteric coated drug, or if you have a lot of food in your stomach, so stomach emptying is slow, what will happen? The absorption will not start immediately after the administration. It's gonna take some time. This some time before the start of absorption, we call it lag. Lag يعني تأخر, delay. That's why it's the time delay prior to the commencement. Commencement means starting of first order drug absorption. هذا هو اللاج time. طيب, how will I discover that there is a lag time? When you are working in residual method, like this one, both line normally should intersect at y-axis, في هذا الأكسس. If they intersect somewhere before the y-axis, sorry, يعني after some time, for example, they intersected here, معناته there is إيش? A lag time. And the point where they intersect is the point, or is the time of lag time. خلينا نشوف, let's see here. Now here we are employing the residual method, and they don't intersect at y, but they intersect at time after that. If we draw a vertical line down, شو وين نوصل على اللاج time. From 0 to this time is the absorption lag time. Is this clear? So this is the absorption lag time. طيب, في عنا another thing which we want to talk about, اللي هو flip flop of KA and KL. Flip flop of KA and KL. شو يعني flip flop? Flip flop here means exchange of KA and KL. طيب, let's talk about this in more detail. Let's say Mustafa has done an experiment where he used the drug that is administered orally or extravascularly, and he collected blood samples, and he did the residual method. شوف, برesidual method always this steeper اللي هو more slope. دائما اللي سلوبه اعلى هو ايش؟ الكي. and the other one is the KL اللي هو السلوب is less. شوفوا الانكلينيشن here, الميلان, الانكلينيشن here is less than here. That's why the higher slope is for KA and the smaller slope is for KL. It's always like this, and that's what we expect, صح? We expect that KA is higher than KL, so it cannot be vice versa, انه او نحكي انه ال KL is higher than K. It cannot be. Okay? For residual method, always KA is higher than KL. طيب, suppose Mustafa did this, and to support his results, شو سوى مصطفى? He injected the sample intravenously. أجا intravenously وinjected the sample. Okay? فشو شاف? He drew a simulograph paper. Okay? في simulograph paper he put the data points and drew the best fitting straight line. طبعا here we have the time, والتايم ممكن بالhour مثلا, وهنا ايش الكونسنتريشن for example in microgram per ml for example. So he calculated CP0, CP0 is equal, don't forget to dose, على V, and he calculated the intercept, the slope, والسلوب equals to ايش؟ to minus KL. إذا Mustafa is able to get KL from IV injection as well as from ايش؟ from an oral administration and the application of the residual method. Okay, he did that. But to his surprise, he was so surprised because KL that he got from the IV injection, which is the accurate one, is actually similar to KA. يعني ال KL, the value of KL from an IV injection, okay, is similar to KA that he got from the residual method. معناته في something wrong. Okay, in this case we assume that there is flip-flop. نفترض انه في عندنا صار flip-flop. انه for this drug KL is actually the higher value and KA is the smaller value. Okay, إذن في عندنا مشكلة هون. Remember the conditions that we can use the residual method. حكينا ايش الconditions? We said that one of the rate constants must be much higher than the other one. Residual method will work. If even KL is much higher than KA, it will work. But ايش؟ راح يصير عندنا flip-flop. Flip-flop in case ال KL is higher than KA. How can I discover that? I can discover that by administering an IV injection and calculating the slope to get KL. Okay, I can discover if there is a flip-flop. Okay, so actually the correct one for the residual method is that the higher slope is for the KL and the smaller slope is for the KA. Remember that this does not happen to many drugs. Actually, successful products that are in the market, دائما بنلاقي KA, or most of the time KA is much higher than KL, so we don't have a problem. We don't have flip-flop. في هناك few drugs, especially experimental drugs, where KL is much higher than KA. In this case, we will expect ايش؟ flip-flop. For example, عندنا isoproterenol, which is used in bradycardia and asthma, has a half-life of only few minutes. That's why I expect إنه ال KL will be much higher than the KA. Okay? ممكن كمان في extended release products, because I am reducing the rate of absorption, ممكن I reduce it to the extent that KL becomes higher than KA and I will get flip-flop situation. طيب, the last thing I want to talk in this video is briefly طبعا is regarding the Wagner-Nelson method. I'm not gonna talk about how to use this method, even though it's quite important, but we want to talk about the advantages and disadvantages of Wagner-Nelson method to calculate ايش؟ KA. لاحظوا, please note that so far I'm only talking about KA. I didn't start talking about F. طيب, calculation of KA. The good thing about this method إنه الريت اوف absorption، او خلينا نحكي rate of absorption constant and rate of elimination constant can have similar values, and this is not a problem. شو يعني مش problem؟ يعني we can still accurately calculate KA and KL. بينما في ال residual method The condition was إيش? The condition is that one of the rates is much higher than the other. To have accurate results, we need to have one rate at least 5 times higher than the other. طيب Wagner-Nelson method, no, they can be similar. طيب شوفوا the other advantage. The rate of absorption, and I'm not talking about the rate of elimination. The rate of absorption does not need to be إيش first order. It can be zero order, it can be first order, it can be first order and then zero order. Actually, this method allows you to test and to find out whether your drug is getting absorbed by first order or zero order, or maybe first order followed by zero order. هذا طبعا advantage. The disadvantage is that unlike the residual method, شوف بالresidual method in the first step we got إيش KL صح? The second step we got KA. Now with the Wagner-Nelson method, the disadvantage is that you must have KL before you can apply the Wagner-Nelson method. You need to have KL. And how will you have KL? كيف تحصلوا KL? You need to give an IV injection. IV injection will allow you to get إيش؟ KL. طيب. Now, whether we are talking about Wagner-Nelson method or residual method, in the end you will get F على V, or better we calculate it as V على F. So we don't get F that talks about the extent of drug reaching the systemic circulation. We don't get it directly, okay? We get a ratio. And this is a problem that we will talk about in our next video. I hope you enjoyed this video and have a nice day.